Here's another WeBWorK problem that you might have trouble with. It's part 2, and it's problem 1. And look at this equation, root 3 sine theta plus cosine theta equals root 2. For this one, look at example 12 on page 523. Notice the parallelism between this equation here in the WeBWorK problem and this one in the textbook example. So it looks like A is root 3, B is 1, and C is root 2. Okay, so here's this equation written down here. A is root 3, B is 1, and C is root 2. So that means that A squared plus B squared is 3 plus 1, right? A squared. So therefore, the square root of A squared plus B squared is 2. The square root of A squared plus B squared is 2, so we divide everything by 2, right? There. 1 over 2 from here. And then this one. Now when you see these two things, root 3 over 2 and 1/2, connections are going to be made in your brain here because you recognize those as the cosine and the sine of 30 degrees. So that means that we can rewrite this equation as cosine pi over 6, right? Sine theta, plus sine of pi over 6, cosine theta. Now back to the original WeBWorK problem. Where are we going with this? We were supposed to rewrite this equation here in the form of sine of theta plus phi equals c. So we went up here and we divided by 2, and then we recognized that we introduced the square root of 3 over 2 and 1/2, which are the cosine of pi over 6 and the sine of pi over 6. Now this is where it's good to have some things memorized. Here's this sine addition formula. Sine of A plus B is sine A cosine B plus cosine A sine B. I have that memorized. And so in my brain there, it's somehow kicking around in my brain, and then I see this, and I say, hey, I recognize two things, two patterns coming together. This right here is like this equation. So connecting the pieces here with A equals theta and B equals pi over 6, you can then use this addition formula to realize that this blue here is the same as this blue up here. So using the addition formula, this right here is this side here, and that's going to be the sine of A plus B, the sine of theta plus pi over 6. So back to the WeBWorK problem, is rewriting the original equation as the sine of theta plus phi equals c. Here it is, the sine of theta plus phi equals c. Now to get the principal solution, right, we're going to take the arc sine of each side. So this side will become theta plus pi over 6, and this side will become arc sine root 2 over 2. Okay, so then that means we get theta plus pi over 6 equals arc sine root 2 over 2, which is pi over 4. And therefore theta, the principal value of theta, will be pi over 4 minus pi over 6. Now let's think a little bit about the next part of this problem. So backing up, we had sine of theta plus pi over 6 equals root 2 over 2. We took arc sine to get the principal value, so theta plus pi over 6 is arc sine of root 2 over 2, which is pi over 4. So that one on the unit circle is here, right? But there's another, possibility. Theta plus pi over 6 could have been, 3 pi over 4, because that has the same sine value. So that means that theta plus pi over 6 is pi over 4, or 3 pi over 4. Then, of course, to each of these you can add 2k pi, right? Pi over 4 plus 2 pi plus 4 pi, pi over 4 minus 2 pi, etc., or 3 pi over 4 plus 2k pi. So that's all there is. I think you can finish the rest of it from here.